Okay, so in the last video we introduced conditional probabilities, and today we're just going to practice some examples of it. So working through, the biggest thing with conditional probabilities is being able to tell the difference between when is it a conditional case and when it is a basic case, right? A case that's out of the universal set. And we're going to look at that in today's set of notes. The examples we'll have questions both basic from the earlier set of notes and then the new conditional cases. Alright, the first example. So I've got a small community. So I'm looking at a small, maybe rural community, where 88% of the households have a cell phone plan. 57% of them have a landline phone, and 48% have both a cell phone and a landline. Now I am going to set up the Venn diagram. You don't have to. You could solve this with formulas only, and I'll do it both ways. I'll show you with the Venn, and then I'll show you with the formulas. Alright, so Venn is just a way to organize our information that we've been given. So remember, this would be my small community, so that would represent one. I don't know how many there could be 5 households, 10, 100, 50, 1,000. I don't know in the small, it just says small community. But the rectangle in the Venn diagram would represent all of them, right? However many there are. Then we're looking at surveying two things. Those that have cell phones and those that have landlines. And so this circle is going to represent those that have a cell phone, and I'm going to use LL for landline. 48% have both, so that goes in the middle wedge here. So 48% of all of the households have both a landline and a cell phone. Alright, then my cell phones, 88% of the people in the community, well, I've already counted 48% that also have a landline. So take my 48% minus my 88, and so that's 40. And so that means 40% of the households in this community only have a cell phone. That's it. They just have a cell phone. And then do the same thing for landline. They said 57% of the households have a landline, a house phone. 48% also have a cell phone, and so 57 minus 48, which means there are 9% of the households who only have a landline. These people do not have a cell phone plan. But then I'm still not done. There's a chance that there's an outside area. It could be 0%. But I believe there is a percent. So you have your 40%, your 48%, your 9%. That adds up to 97%. Subtract away from it. So there is a small percentage. 3% of the people in this small community do not have a cell phone plan nor a landline, which means either they're totally off the grid and they have no phone whatsoever, or maybe they have like a burner phone that has no plan. Alright, so 3% of them have neither a landline nor a cell phone plan. Again, this is just a way to organize my information. Now the probabilities. What's the probability that a household in this community has a cell phone or a landline? And so what you're going to have to recognize is the first question now, is it a basic probability or is it a conditional probability? And the question is answered by where am I selecting from when I'm finding my probabilities? And so we're selecting from a household in the community, which means any household could be selected, right? Any household can be selected, and so this would be out of the universal. So this is a basic probability. So probability, they have a cell phone or a landline out of all of the households. How many of them have a cell phone or a landline? So this is a basic probability. This is what we did in the first few sections. And since it's the or, I'm going to use my union formula. Or I can use the Venn diagram. It's all of the households that land in this circle or this circle. And so using the rule, the union rule, if you didn't have your Venn diagram, you take the probability they had a cell phone plus the probability they had a landline minus the probability they had both, right? A landline and a cell phone. Right, so 88% have a cell phone, 57% had a landline, and 48% were counted in both. And so that came out to 97%. Written as a probability, that's 0.97. Again, that's using the formula. You don't have to use the formula, though, if you have the Venn diagram. It's just all of the people that land in these two groups. When these people make up 97% of the community, right? 97% of the community land in the cell phone circle or the landline circle. Right, so again, either way is fine. I encourage Venn diagrams because I think it's just an easy way to recognize what's happening. But you could use the formula as well. Alright, part B. What is the probability that a household with a landline phone also have a cell phone? And so this one's different. The previous problem said the probability that a household in the community, meaning every possible household could be selected out of my community. The second problem is not that case. This is a conditional probability. Probability that a household with a landline, we're given they have a landline. If they have a landline, what's the odds they also have a cell phone? And so that's different. And so this is a conditional. Probability they have a cell phone, right? We're looking for that chance. What's the odds they have a cell phone given they're a house with a landline? Well, it would be the probability that they have a cell phone and a landline divided by the probability they have a landline, because we're given that we're in this circle, right? This circle is given to me. I'm inside the landline circle. And so I already narrowed it down. I'm not looking at 100% of the households anymore. I'm only looking at the 57%, right, the circle, that have a landline. Right, so out of the 57%, and you can write that as a decimal. It's proper to write it as a decimal, but if you had written it as a percent, that's okay too. The ratio is the same, as long as you're consistent. So if you write the probability of a landline as a decimal, you need to write the probability they have a cell phone or a landline as a decimal, and that was 48%. Again, you could do the fraction either way, just be consistent. If you convert all of them to the decimal probabilities, make sure both are converted. If you leave them as percents, you can leave them as percents. The division of both of these numbers is the same. It's the same fraction. And when you divide those out, it comes out to 0.8421. And so the odds change, right? If I were looking at the universal set was out of all households, well, that was 88%. Right? If I'm looking at the entire community, and I pulled somebody from the entire community, I had an 88% chance of getting somebody with a cell phone. If I'm looking at just the houses with a landline, I've narrowed it down to the 57% of the houses with a landline, the odds go down. Instead of having an 88% chance, I now only have an 84%. They're not much different, but they are different. The odds of finding somebody with a cell phone if they have a landline is only 84% chance. Right? And so again, conditional. And it's very subtle. You have to read the problem very, very carefully. Right? And note, am I looking at everybody? And am I pulling from the entire group of people, the universal set? Or am I looking at a conditional group, a given group? Right, I've put a condition on it, given they have this instead, and this time the given was the landline. Alright, the last question for this particular problem. Oh, percent. So I've got to write it as a percent. What percent of households in this community? Alright, so what is the percent of households in this community without any type of phone? And so again, it's more like the first example. Household in the community, in this community. So I have an option of picking anybody from the community. If I pick anybody from the community, what percent of them do not have any type of phone? What's the odds of getting it? Somebody with no phone, or neither of these types of phones. Well, that's that 3% out here, right? That's why Venns are kind of nice. 3% chance. If you did do this with a formula, it would be the probability that you have none of the phone types, so probability you do not have a cell or a landline. Okay? And so you'd have to take 1 minus the probability that they had a cell phone or a landline, which would be 1 minus our 97%, and it comes out to our 3%. Okay? And that would be if you're using a formula. But this one particularly is a lot easier to find using the Venn diagram. So I encourage you to use the Venn diagram in this case. All right, Alright, the next example, the second example on this page, is a table case. So we've got a table. The table is broken down into, we have 87 students, and we've got them grouped by men and women, A, B, C, D, and F. Alright, so again, out of the group, there's the different cases. So now again, the problem now is that we've added conditional probabilities, and so I've mixed together conditional cases with basic cases, and the biggest thing is to recognize the difference between the two. And so I've sort of highlighted in this set of notes the important piece of information that's telling you which case it is. And I encourage you to do the same thing when you're reading through yours. So read the problem carefully. Ask yourself, am I pulling out of the universal set? So can anybody be selected? And then looking for a particular probability. Or am I pulling out of a conditional group? Not everybody could be selected, only this group of people. And then the probability I get my event. Right, so the first question, what is the probability of randomly selecting a student who is a female or received a B? And so randomly selecting a student. Student means they can be anybody from this class, right? They can be any of the 87 students could be selected. So I'm selecting in the universal case. So this is a basic probability. Alright, universal set's where I'm selecting from. Alright, so probability that they're a female or received a B. Well, I'm going to use my formula, probability they're female, plus the probability they're a B student, minus the probability they're both. Alright, the AND statement. Alright, so out of the universal set. So the chance of picking a female student out of my group would be 53 out of 87. So 53 out of 87. Plus the probability they're a B student, so there's 35 B students out of 87, minus anybody I counted twice, which if I look here, these 19 students were both female students and B students, and so I counted them in both groups, so I gotta make sure I subtract away that 19 set. Alright, so 53 plus 35 minus 19 comes out to 69 out of 87, so there are 69 female students or B students out of all of my students, my universal set. And so then I find the decimal approximate, which is a 97% chance that I do, if I'm picking out of my group of students, I'm going to get a female or a B. Right, so universal case, basic case. Second example. As soon as you see the word given, you should always kind of make you wary that this is a conditional case, right? Because that's A given B, B given A. Right, given, you randomly select the student who did not get a C or better on the exam. What is the probability you picked a female student? So again, given that you selected a specific type of student, so the difference here is a student who has something we know about them. I'm not selecting all possible students anymore. Not all of my students could be selected. Only those students who did not get a C or better in exam. So if they didn't get a C or better, so that'd be a C, B, or A, so who got a D or F, right? Those would be the group. If I'm only looking at the students with a D or F, what's the chance, if I select one of them, I get a female student? So conditional. Probability that they're a female is the one I'm looking for, but I'm only looking at the D or F students. So it's the conditional formula. Number of D or F students is what I'm going to be pulling from, right? I'm no longer pulling out of all 87. I'm narrowing it down to just the D and F. So I'm selecting from only that group. So that's what I divide by, what I'm selecting from. I'm selecting a D or F student. If I select a D or F student, what's the chance that they're female? So up top is the AND statement. Female and D or F. Well, I go figure out what that count is. Alright, so again, I'm only looking here. That would be the total, all of my D and F students. I've got 13 Ds, 6F, so there are 19 D or F students. So out of the 19 D or F students, well, how many are female? Well, that would be this group, right? It's the female student. So 7 Ds, 4 Fs, so 11 total students are female, and they have a D or F. So out of the 19 D or F, I've got 11 chances of pulling a female student, and then I find the probability, which is 0.5789. So about a 58% chance, if I'm selecting a D or F student, they will be female. Our next example. What's the probability that a randomly selected male did not get an A on the last exam? So again, I'm not randomly selecting any student. I'm picking from a specific group. I'm randomly selecting a male student. Alright, so it's a conditional. And then I'm looking for the chance they didn't get an A. Alright, so probability, they did not get an A, given I'm only selecting the males. Alright, so I divide by the number of male students because that's who I'm selecting from. I'm not selecting any student. I'm only selecting from the male group. So given they're a male student, what's the probability that they did not get an A? So it's the number that did not get A's and they were men. Alright, so I go figure that out. So again, I'm going to narrow it down. I'm only looking at the male students, right? And so this would be my total. So there are 34 male students. So I'm only picking out of 34. Out of the 34 I'm selecting from, how many of them did not get an A? So the easiest way to do that is actually to use the complement. These would be the 2 of them got an A. So I take 34 minus 2 to get 32, or you could add 16, 8, 6, and 2. You should get the same answer. So 32 of the students are male students that didn't get an A. They got a B, C, D, or F. And then find the probability, which is, again, is fairly high probability. 94% chance. Alright, 0.9412. So if I'm picking from the male group, right, so given that's where I'm selecting from, so that's conditional. Out of the 34 male students, I pick a student, I've got a 94% chance that they did not get an A on the exam. Alright, the last example for this problem is to highlight the difference between conditional and basic and how they're very subtle but very important that you recognize the differences. And that's the tricky part about now that we're adding conditional probabilities. So the last part, part D, what is the probability that a randomly selected student was a male student that did not get an A on the last exam? Alright, so the wording is just changed up a little bit, but that change makes a very big difference in the outcome. I'm picking a randomly selected student. Student would be any student could be selected. So this is universal case, right? The basic case. I'm selecting out of my entire pool of students. If I'm selecting out of my entire pool of students, the universal case, then what was the chance they were a male student and they didn't get an A on the exam? So probability they were a male student. And they did not get an A. What would be the number of ways to get a male student and not an A over this time the universal, because any student could have, pulling out of everybody. So if I'm pulling out of everybody, what's the odds I get a male who didn't get an A? Well, the odds change if I'm pulling out of everybody, right? Because there are 87 possible students I could pick from. Out of those 87, 32 of them were male students who did not get A's. That number's the same. The number that changes is what I'm dividing by, because it's what I'm selecting from, and the odds change. Right? I now only have a 35, almost a 36% chance. So when I take 32 divided by 87, it comes out 0.3585. And so it depends, it makes a big difference where I'm selecting from. So the conditional means I put a condition on where I'm pulling people from. In this case, in the first example here, in this example C, I picked the men, right, which I was only pulling out of the 34 men, and then the odds of getting an A student was 94. If, instead of pulling out of just the male students, I pull any student, which they could be men or women, that's the entire class could be selected, that changed my odds. I now had 32 chances out of 87, and so my odds decreased significantly, right? It was a big change. I actually think that number might be wrong. Let me check it again. Just give me a second. I think I might have typed in the next answer. 32 divided by 87. And I did. This is 3678. So make sure, change this. 32 divided by 87 is 3678. So make sure you change it. The 3585 actually is the answer to the next question. In case you want to know, that's the one you're supposed to try on your own. Alright, so make sure you correct that in your notes. So erase what I had up there before, which was the 3585, and write 3678. So 32 divided by 87 is 3678. Alright, so again, make sure you make that change. But this last problem here is to reiterate again the subtle difference between basic probability, which is this case, versus conditional probability. And again, sometimes it's very subtle. Right? It's not 100% again clear. That's why you need to practice these mixed together so that you understand the difference between them. And this is a good example to go back and refer to when you're looking at the difference between basic, which is the universal case, or the conditional case. Alright, you are supposed to try this last one on your own, so see if you can't set it up. It was the example I put up there, the 3585 was the answer to this one. Alright, so try it on your own though, see if you can't come up why it comes out 3585 is the answer. Alright, it is a conditional probability, and make sure you try that one on your own. Alright, I'm going to wrap up that video there. Keep these videos fairly short in case you want to refer back to them, and we'll pick up the next page of notes in the next video.